What's up, everyone? This is Ankit from EcoSikho, and we are back with video number 2 on quadratic functions from our Math AI IB syllabus. So, in video number 1, we talked about what is a quadratic function. We talked about how the graph of a quadratic function always results in a parabola. We talked about different parts of a parabola. We have vertex, we have axis of symmetry. Okay, we talked about two special types of parabola in this syllabus. We can either get a concave upward or we can get a concave downward. Then we talked about the x-intercepts and the y-intercepts. And finally, we talked about some basic forms of an equation. Like we talked about the factored form, and if we are given an equation in a factored form, what are the x-intercepts, axis of symmetry, and vertex? We talked about the completed square form, and we talked about a very important thing, that is the value of a, the coefficient with x square. So if a is greater than 0, we get a concave upward. If a is less than 0, we get a parabola which is concave downward. And if a is equals to 0, we get something known as a linear equation. Okay. We also talked about how the value of a can affect the shape of the parabola. So if a lies between -1 and +1, we get a curve which is wider than y is equals to x square. And if a is less than -1 or if a is more than 1, we get a curve, we get a parabola which is narrower than y is equals to x square. So that was all in video number 1. Let us now move ahead with video number 2. And in this video, we are going to talk about how to sketch the graph. Like we'll be given a equation of a quadratic equation, okay, a quadratic function. And we will be doing some graphing, like we'll be trying to plot it on a graph. So first, let us start with the completed square form. And let me do some examples. So in a completed square form, let's say I have been given y is equals to x squared plus 4x plus 3. And I have been told to plot this function onto a graph using the completed square method. So I should know how does a completed square method looks like. So it looks something like y is equals to x minus its whole square plus k. And if I'm given a equation which is in the general form, first I will need to convert it into the completed square form. So this equation can be written as y is equals to x whole square plus 2 times 2 times x plus, let me add a 4 here and let me subtract a 4 here, and plus 3. So I have added like a 4 and a minus 4. The reason behind it is I want to make sure that this part gets converted into a form of a minus b's whole square so that I can get a equation in the completed square form. Okay, so next up will be y is equals to, this part can now be written as x plus 2's whole raised to the power 2 minus 1. Or I can write it in the form of y is equals to x minus of minus 2 whole raised to the power 2 plus minus 1. Okay, so this is the equation in the completed square form. And I should know one thing from our last class, from our last video, that if this is the completed square form, then the axis of symmetry should be x is equals to minus 2. Axis of symmetry is a line that divides my parabola into two equal halves. So that should be the axis of symmetry. That should be the equation for the axis of symmetry. Okay, I should know that the vertex over here should be minus 2 and minus 1. Okay, to plot a graph, I need a certain things. I should know the axis of symmetry. I should know the vertex. Vertex is also the turning point. It tells me that the what is up with everything. Okay, and also in the general form, I can see that x square is accompanied by a 1. So since a over here is more than 0, I can conclude that it is a concave upward parabola. Okay. What else? I got the vertex. I got to know that my graph will be a concave upward. I got to know about the axis of symmetry, but I still need one or two more points to be able to perfectly make the graph. So let me try to find out the y-intercept. Okay, so the y-intercept is a point. So if I try to do a rough here, just to visualize what I have gotten so far. So minus 2 comma 1 lies somewhere around here, and it is a concave upward parabola. So something like this. But still, I'm not very sure that why when it will cut the y-axis. So I need to find out the y-intercept. So y-intercept can be found by taking the value of x is equals to 0 in the equation, in the original equation. So let me find out the y-intercept. So for y-intercept, what I will be doing, I will be doing x is equals to 0. I can use this equation. So y is equals to 0 minus of minus 2 gives me plus 2 whole raised to the power 2 plus minus 1. So that's 4 minus 1, that's 3. So I got to know that my parabola is definitely gonna pass through a point 0, comma 3. My parabola is definitely gonna have a y-intercept of 3. So next I will be locating the 3, which lies somewhere around here. And that gives me an idea that this is how the parabola will rise. So yes, we are done. So that was about how to find out or how to sketch the graph of a completed square formed parabola. Okay. So I hope that was fun. And let's move to the general form. So we know that in the general form, the quadratic equation looks something like y is equals to ax square plus bx plus c. We also know that, sir, if the quadratic equation is ax square plus bx plus c is equals to 0, it has got two roots. Okay, it has got two solutions. And the solutions of this particular quadratic equation will be minus b plus minus under root of determinant upon 2a. This value will exist. The solution to this quadratic equation will be called as a x-intercept if and only if the value of determinant is greater than equals to 0. Okay, so if you are forgetting what is determinant is basically b square minus 4ac. Okay, so if we are ever given a parabola's equation in the form of a general form. Okay, so we need to sketch it, and to sketch it, we need certain information. Okay, so what can we say about this equation over here? So we can say that the axis of symmetry is an equation of the line which is x is equals to minus b upon 2a. Sir, how come we are getting this? We are getting this because there are two roots of this equation. One root is minus b plus under root of determinant by 2a, and the other one is minus b minus under root of determinant upon 2a. So if we take the average of these two solutions, we get minus b by 2a. A quadratic equation in the general form, the axis of symmetry has a equation x is equals to minus b by 2a given the value of determinant should be greater than or equals to 0. That's the first thing I need to look out for. Okay. Second thing, the vertex. And we know that vertex is a set of coordinates of x and y. So the vertex will have a x coordinate. Okay. We are not talking about the y coordinate. The vertex will have a x coordinate of minus b upon 2a. We don't know about the y coordinate. Okay, so if we want to find out the y coordinate, we can substitute the value of x in the equation and we will get the value for y. Okay, so let us use this information and let us try to sketch a graph. Okay, so let's see. Okay, so let's say I have been given y is equals to 2x square plus 8x minus 10. And I need to sketch this equation, this quadratic. Okay. So first thing first, I can clearly see that the value of a is greater than 0. So whatever I will be getting, okay, so the value of a, which is equals to 2, is greater than 0. because a is the coefficient of x square, the constant number which is with x square. Okay, so I know this thing indicates that I will be having a concave upward parabola. Secondly, let me try to find out the value of determinant here. So the value of determinant is b square minus 4ac, which is 8 square minus 4 into 2 into minus 10. That's 64 uh, plus we have here 80. So that is something which is greater than 0. So this thing indicates me that the solutions are minus b plus minus under root of determinant by 2a. So now that this point has been established, I can say that the axis of symmetry will have a equation x is equals to minus b by 2a. And over here, minus b is minus 8 upon 2 times 2, which is minus 2. X is equals to minus 2. That's the equation for axis of symmetry. Okay. I should know that the vertex will have an x coordinate of minus 2. The same value I can use it because the vertex will have a coordinate of the same minus b by 2a. Okay. Since I know the x coordinate is minus 2, I can use this in the equation to find out the y coordinate. So the y coordinate will be 2 times minus 2 whole raised to the power 2 plus 8 times minus 2 minus 10. So that gives me what? 8 minus 16 minus 10. So that gives me 8 minus 16 is negative of 8, minus 10 is negative of 18. Okay, so the vertex has a coordinate of minus 2 comma minus 18. Is it all? I know it's a concave upward parabola. I know the axis of symmetry is the line x is equals to minus 2. I know the turning point of the parabola is minus 2 comma minus 8. But I still need one more point to be able to perfectly draw the quadratic. So that point can be your y-intercept. And to find out the y-intercept, we need to take x is equals to 0 in this equation. So the third is let me find out the y-intercept by taking x is equals to 0. So in the given equation, I know y is equals to 2 times 0 raised to the power 2 plus 8 times 0 minus 10. So I got y is equals to minus 10. So that's the y-intercept. So now we are all done and set and ready to plot the graph. So over here, this is my Cartesian plane. And I know the axis of symmetry is a line. X is equals to minus 2 if I'm not wrong. Yes, it's x is equals to minus 2. Point number 2, I should know that the vertex has a coordinate of minus 2 comma minus 18. Let me assume that minus 2 comma minus 18 is somewhere around here. Okay, and I know that the y-intercept is minus 10. Okay, so minus 10 lies somewhere around here. So I have everything now to plot the graph. So this will go like this, and I will be a bit careful since this will also go like this. So that's how we plot the quadratic when it has been given to us in the general form. So I hope that was fun, that was interesting, and you liked it a lot. So show me your love by please hitting the subscribe button, by liking the video, and by sharing with it with your friends, and also by commenting what is the next chapter that you expect me to cover. Okay, so I will see you all in video number 3, where we will be talking about how to use the discriminant to tell us more about the quadratic. We'll talk about positive definite, negative definite, and there's a whole lot of other stuffs in function. So that's all for now. Thank you so much, everyone. Have a great day.